Okay, sorry for the video not uploading this morning. I think that website crashed. So here's a separate one. It's not going to be quite as pretty. It's going to have some different problems on it. All we're doing today is taking the derivative of different types of functions, whether those be exponential or logarithmic. So for this first one, a to the u power, a would be a constant value. So for instance, 2 would be the base, or 3 or 4 or whatever it might be. And u would be some function. It could be x. It could be an x plus 2. Okay, it could be an x plus 2 squared. Okay, whatever it is, basically u stands for the exponent to that exponential function, where a is talking about the base. Okay, so this is going to be like our base, and this is going to be our exponent. Okay, so for a function that is y equals a to the u power, the differentiation rule, y prime, is going to be just a to the u power, the same exact thing, so it's going to stay the same. Then you multiply times the natural log of just the a value, just the base, and then you multiply that times the u prime value, so the derivative of u. So you're just going to copy down a to the u power to start, then just take ln of a and then u prime. E to the u power is a different exponential function. That's going to be whenever the base is e. So specifically when we have a base of e. And once again, the exponent could be anything. That u could be like an x plus 1. It could be an x squared. It could be an x to the third. It could be a 3x to the fourth plus 95 cosine of pi. Whatever it is, that's going to be up here as the exponent. So let's just use an example of, let's say this was e to the 2x power. Okay. So e would always be our base, and this time the u, okay, would be that 2x. So let's look at how we would take the derivative of something like this. Okay, so y prime is going to be, well, this time we're still going to recopy e to the u, just like that first one. But this time we don't need the ln of a, because if you think about it, our base is e. And if we take the natural log of e, those are opposites. Those would cancel out to give us a 1. So we don't really need that. So we just need to do e to the u times u prime. So really just copying down and then multiplying times the derivative of whatever your exponent is. Okay, the next one is your log and natural log functions. So an example A would be like our base. So an example of this would be like log of base 2 of some argument, and that could be some kind of function as well. Let's call that 2x plus 1. Okay. So we'd have to identify what is our base and what is our argument. And then when we find that, our derivative is going to look like this. 1 over u times ln of a times u prime. All right, so once again, just identifying, okay, what is u? All right, and our u would be the entire argument, and our a would be whatever that base is, that regular number. All right, and then finally, for a natural logarithm, this is actually going to be much better because remember that this has a base of e. You don't need to write that in there, it's assumed. So when I come up here and I use my base on the inside, ln of e, that again, those are going to cancel each other out, so we don't need that. So our derivative function for any natural log is just 1 over u times u prime. All right, and once again, this would be like for any function that has a natural log in it. So let's say natural log of, I don't know, x to the fourth over 3. Okay, any function really in there. Okay, we can use this kind of formula for. All right, so take a moment, make sure that you have these in your notes. And what I would write is I would write these two things kind of together, these two things kind of together, all right, et cetera, et cetera. But make sure that you have all 4 of these examples included in your notes. We're going to need those in a second, and they're going to disappear. Copy, 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 copy. Pause. Okay. So now let's go over some examples. If you were in class today, you were here for examples A, B, and C. So we'll just kind of redo those really quickly. And then we'll do examples D, E, and F as well. So I'm going to go really quickly. So the first thing that I see here is that I have, this is a function that looks like e to the u. Okay, I just identify that, so I know that I'm going to use the formula e to the u times u prime. Okay, that was just from up above. So now that I have that, I just have to identify what is my u. Okay, the u is right here. So let's kind of come up to the side. U is x squared plus 2. I'm just kind of organizing my work here. And u prime is going to be, well, let's take the derivative. Move the 2 down. That becomes a 2x to the first. Derivative of constant is 0. So this is everything I need to solve this problem. So now I just need to put it all together. I'm using y prime. I should be using f prime of x. I'm sorry. So e to the u. All right, now I'm just going to keep the e. And what was my u again? Okay, that was x squared plus 2. So I'm basically just keeping the entire first thing the same. And then I'm going to multiply that times u prime, which is 2x. I'm done. The only thing that maybe I could do differently is just kind of pull that 2x out front as a coefficient, but that's it. There's our answer. So just kind of highlighting some things here. We started by just writing down which function and what derivative I would want to use in this problem. And then from there, I was going through and actually figuring out what our letters represented. So if I know that this is e to the u, I can see that I left my e in there, right? That happened in every single one of these. And then instead of having a u, what I did is I actually figured out, okay, what was the u? Okay, so u was this whole thing here. So wherever there was a u, I put an x squared plus 2. And for my u prime, I just actually went down and I took the derivative. So there was my u prime, which I did that work off to the side, which was right there, 2x. Using my formula, identifying what it is, and then putting things in the correct order. The next example, we'll call this, okay, so this is a natural log. So up above, what I have is I have y equals ln of u. Okay, that would be the natural log. And to take that derivative, we would do 1 over u times u prime. Okay, so just having that information in front of me is so critical because now I can understand what do I need. I need to find out what u is here. Okay, so in my derivative, I need u and I need u prime. In my derivative, right here. Sorry, right here and right here. Okay, so let's find out what u is according to this. All right, let's look. U is just the argument, so u is just 8x. And the derivative of that, now I can do that work. So that's an 8x to the first, bring the 1 down to become an 8. X to the 0. Okay, it just becomes a 1, so 8 times 1 is just 8. All right, I have everything I need, so now it's just putting this in the correct order. So y prime equals 1 over 8x times 8. That would be our final answer, but what I'm going to do is I'm going to go one step further by just making that 8 over 1 and putting this together. Once again, I should put this as f prime of x as my final answer because that's how it was represented at the beginning, even though that means the same thing. So f prime of x is going to be 8 over 8x, and those 8s are actually going to cancel each other out, so this is going to be 1 over x. So this would be like their final simplified function right here. Okay, f prime of x equals 1 over x. Any one of those in between would have worked. Notice how I just first wrote down my equations, okay, and the derivative. Then I came off to the side and identified what I needed, and then I plugged that all in, and then I simplified it. The next one, I have to identify which function I'm using. So this one, let's see, it's an exponential function. I know that because remember off to the side, what we've done in the past is we've done stuff like this. This is not exponential. If the base is an x, that's when we can use a power rule. But here we cannot because the base is actually a regular number. So this would be like y equals a to the u power. So we can't just move down the u and subtract 1 from that if the base is a number. What we have to do is the following formula. So y prime equals, this is going to be a to the u times the natural log of A times U prime. So there's a lot of things that we need in this problem. So let's just identify what those things are. All right, need an A and a U, and we need a U prime. So I'm just going to identify those off to the side. Okay, what is A? All right, let's look at our kind of original here. A is that bottom number, our base. So in this, our A value is going to be 10. Our U is going to be this entire function that is our exponent, tangent of x. And then U prime. Some of you may remember what the tangent of x's derivative is without having to use the quotient rule, like doing sine and cosine and all that kind of stuff. It's going to be secant squared. And you can just look that up in your notes, secant squared x. So now that I have all this information, it's just a matter of putting this into the correct order to get my f prime of x. So a to the u is just going to basically stay the same as our original, a to the u power. So 10 to the tangent of x power times the natural log of a, which is 10, times the u prime, which is secant squared x. This would be it. This would be our derivative. This is about as good as it gets. We really can't combine anything here. We have three distinct terms being multiplied together. This times this times this. There's no distributing that can happen. I could just change the order of those things if I wanted to. So just look for those in a different order on a multiple choice question. Done. Okay, so take a moment. If you need to write down anything, take this moment to write it down because all of these are going to go away. And we're going to talk about the next three. Okay, the next three are as follows. So this next one is definitely like a challenge type problem. The reason why this is a challenge type problem is because, yeah, we do have this, which is what we normally have been, what we did up above, but we also have this. So this is going to be the product rule. And I know this is a product rule because I'm actually multiplying two different functions together. So let's see. I've got to go off to the side, x to the third and e to the x. And I've got to find the derivatives of each one of those. Okay, so the derivative of x to the third is 3x squared. That part, not too bad. E to the x, all right, well, how do I take the derivative of e to the x? So let's just remember, if I have something like e to the u power, y prime is just going to be e to the u times u prime. So I'm actually doing my derivative off to the side, then I can put this all together at the end. All right, so now I need to figure out, all right, what is u? All right, u is, in this case, just the exponent, so just x. So if I were to say, okay, u is just x, our u prime is going to be, let's see, what's the derivative of x to the first? That would be 1x to the 0. We don't need x to the 0, so just 1. Okay. Why we did that is so that we could finish the derivative of just e to the x power. So y prime of this would be, let's see, we're going to keep e to the x, and we're going to multiply it by the u prime, which is just 1. So that whole thing is actually going to stay e to the x. Interesting. So our derivative for e to the x, actually in this case, was e to the x times 1, or just e to the x. We did that so that we could use this product rule to continue finding that derivative. So remember that with the product rule, we have to go in a very certain order. We have to go from here to here, and then add from here to here. Remember that was like u prime v plus u v prime. So that would be 3x squared times e to the x plus x to the third times e to the x power. This would be our final answer. F prime of x equals all of this. There are some things that we can do, like we could change the order of these things again. Other things that we can do is we could actually group things together, like factor out an e to the x, and that could be like a 3x squared. Think about like the opposite of the distributive property. Why I'm showing you this is not because I would expect you to do this to your answer, but I'd expect you to notice this about a multiple choice answer. So basically, if this was an answer choice and you were to multiply those two things back in there, we would get the same answer as what we got up above for our derivative. So why was this one difficult? Well, we had to multiply two different types of functions together, which means we had to use our product rule over here. And not only did I have to use the product rule, I also had to remember, how do I take the derivative of something like e to the x power? And I had to use this formula as well. So there are several formulas happening in this problem. So that's why it's really important to organize our work, have a step-by-step approach, and then put all that stuff together at the end. Our last one is our last two. So this one is going to be log base 4. So let's see. On this one, we have a log base a of some function u. So I'm just looking at my formulas from up above, identifying that as a log function. For one of these, we have to do 1 over, and that's going to be 1 over, let's see, u times ln of a times u prime. Okay, so once again, this was a u here, not an a. Okay, so for this one, there's not really any, there's no product rule, quotient rule, thank goodness. We just have to identify our a, our u, and our u prime. So since I'm running out of space, I'm going to kind of do this off to the side or down below. You have to identify our a, our u, and our u prime. Okay, our a value is the base. Okay, so let's look at the very original problem. What is our base? Our base is 4. Okay, so that's going to go in wherever that a is as well. Our u, let's look at our original. Okay, what is the argument? What is the function inside right here? That's going to be a square root of x. All right, so now I'm going to also need u prime. So remember that square root of x is x to the 1/2 power. And when I do that, we have to move that 1/2 down, subtract 1 from it to get a negative 1/2. And then from there, we're putting that radical on the bottom with that x, all right, because x to the 1/2 is a square root, and it goes on the bottom because it was a negative. So this whole thing would be like 1 over 2 radical x. Now with that being said, we did that so that we would know a, u, and u prime. So now we can put this all together at the end. So let's think, this is going to be our y prime value. This is going to be our f prime of x. Okay, so I'm going to start with 1 over, let's see, I got a u to start. So 1 over u times, let's see, square root of x times ln of a, which in this case was my base I've identified as 4, times u prime, which I identified down here as 1 over 2 radical x. Now this is our f prime of x. This is our derivative. There are some things that maybe you could do here. So think about like when you multiply these two things together, what we're going to be doing is we're going to be multiplying this times these two terms here. So think about your distributive property. And you can kind of put those things together that way. But aside from that, this is how I would keep it for now. All right, the last example. ln 2 e to the x power. Okay, so this is actually going to be like a 2-in-1 type thing. So the first thing I see is that I'm going to have y equals ln of something a. Okay, now if I have y prime of that, all I have to do, sorry, not a, you use the letter u to identify that function on the inside. So y prime would be 1 over u times u prime. Okay, so let's just identify what u is. In this case, u is e to the x. So I'm going to have y prime equals 1 over e to the x times, now I'm going to need to actually get u prime. So if this is u here, right, I need to find u prime. Okay, well, what's difficult about that is now I have to reuse a formula to find my derivative for e to the x power. So if I have something like e to the u, right, To find my formula, I actually have to do e to the u times u prime. This is the same formula as up above. So in this case, that was my y prime. My y prime is going to be e to the x times the derivative of that exponent, which is 1. And we've already kind of done this one already. So the derivative of that is actually going to stay e to the x. So if I take the derivative of the inside e to the x, I get e to the x in a weird kind of twist of fate. So I'm going to put this all together now by putting those things on top. So my final answer here for the entire final derivative after using both formulas is going to be e to the x over e to the x. And we know that if we ever have something over the same thing, that's just going to be one whole. So f prime of x is going to be equal to 1. Now there may be some holes in there, and there might be some domain restrictions on this based on the fact that we can't have a 0 in the denominator. But aside from that, we're good to go.